internet. And I'm gonna use this one. Copy and this one. To go to the Google Chrome. Yes, sir. Okay. In cloud in lab stream. You have to go to another. Yes, this one. Six. Yes. It's SCI33205 M604. Open wiki. Okay. Yet meeting and finish. Right, finish. Okay. Sulapawin. Nothing wrong, right? โอเคทุกคนได้ยินผมไหมครับหรือว่าไมค์ผมเจ๊งอะไรไม่เอ่ยทุกคนได้ยินผมไหมครับผมมาจากผมอยู่ที่iPad นะครับก็ไม่รู้ว่า the microphone is out there right and what about thisโอเคไหมครับlet me check just, no. Please use this one.โอเคทุกคนได้ยินผมไหมครับ Hello not sure what happened okay okay อาจารย์ได้ยินไม่ได้ยินครับไม่ได้ยินครับwhat happened my god ฮัลโหลครับได้ยินกันไหมครับฮัลโหลเลยได้ยินแล้วครับได้ยินคุณแล้วครับได้ยินแล้วครับโอเคครับโอเคso we have to continue okay this one okay but yes okay let's continue our story วันนี้ไม่เช็คชื่อแบบกล้องนะครับตั้งแต่หลังเป็นต้นไปนะเพราะว่าเสียเวลาคุณครับมีคนบ่นนะครับแล้วก็ผมก็คิดว่าอย่างนั้นเช่นกันครับเพื่อให้ง่ายที่สุดนะครับกลับไปใช้วิธีเดิมของเรานะครับก็คือพิมพ์ชื่อมานะครับพิมพ์ชื่อในทางไหนดีทางแชทของ Zoom แล้วกันเนาะหรือว่าถ้าใครอยู่ที่ YouTube ก็ผมไม่ได้ส่งลิงก์ YouTube ให้นะครับถ้าใครอยู่ที่ YouTube ก็พิมพ์มาที่ YouTube ก็ได้นะครับโอเคทุกคนได้รับคะแนนนะครับถ้ามีข้อผิดพลาดสงสัยตรงไหนนะครับก็ให้รีบบอกผมนะครับสำหรับคนที่มีปัญหาคือเหมือนว่าการตะพลก็นะครับครับก็คุณครูเขารอเขาเรียกว่าอะไรรอรับงานคุณนะเพราะว่าเขาจะต้องแก้ไขให้คุณนะครับวันนี้ทุกคนได้รับเขาเรียกว่าอะไร18แล้วทำไมผมมีไลฟ์2อันทุกคนได้รับคะแนนทุกคนได้รับคะแนนformative คะแนนเก็บอะไรเรียบร้อยแล้วนะครับแล้วก็คะแนน midterm ครับก็ถ้าผมตรวจผิดพลาดยังไงขออภัยด้วยครับเพราะว่าไม่ได้หลับไม่ได้นอนครับช่วงนั้นสมองล้าๆครับ what else this one and another one so we can have 2 stream at the same time ครับมี2 channel นะครับไลฟ์ของอีกเครื่องหนึ่งครับไมโครโฟนอีกตัวนะครับแล้วก็อันนี้ไลฟ์ที่ forward จาก Zoom ไปครับไลฟ์จาก YouTube สัญญาณมันอาจจะไม่ค่อยดีเท่าไหร่นะครับผมไม่รู้เพราะอะไรเดี๋ยวเปลี่ยนเน็ตให้เขาดีกว่าไหมokay so let's continue our story you just write down your name in the same way as we have done at the beginning of the semester in please use the English word okay กันพลธนนัทนะครับพยายามเขียนเป็นภาษาอังกฤษเพราะว่าผมจะได้ดูง่ายๆคุณจะเขียนภาษาไทยคุณวงเล็บมาด้วยก็ได้เพื่อว่าบางทีคุณไม่ชอบที่ผมออกเสียงชื่อคุณไม่ถูกเนี่ยเพราะว่าผมอ่านจากภาษาอังกฤษแล้วมันก็จะไปเป๊ะเหมือนภาษาไทย 100% ครับคุณวงเล็บมาแล้วกันนะครับถ้าอยากให้ผมออกเสียงชื่อคุณให้ถูกนะครับไม่ต้องเปิดกล้องแล้วนะครับเสียเวลานะครับ เราว่ากันตรงนี้เลยนะครับกาซิดิตโอเค and what else ที่ YouTube ใช่ไหมครับงั้นผมต้องเสียบอีกอันหนึ่งI'm gonna use another one instead of that ที่ซูมมีปัญหาไหมครับที่ซูมครับซูมมีปัญหาไหมเอ่ยis there any problem otherwise I'm going to use the SIM card okay it's 4G and what else chat you have one more message โอเคนะครับก็จะพิมพ์ชื่อเอานะครับเช็คชื่อคุณตามที่คุณพิมพ์นะครับ and then what else I need to share screen right everything here microphoneทุกคนได้ยินผมนะครับแชร์หน้าจอให้อยู่นะครับไม่รู้ไปไหมเอ่ยฮัลโหล okay I hope that you can hear me right ทุกคนได้ยินเสียงเรียบร้อยนะครับได้ยินเสียงผมไหมครับ can you hear me ได้ยินเสียงผมไหมครับ if not say noโอเคได้ยินนะครับโอเคพี่รันนะครับพี่รุ่นตอบแล้วโอเคthen we will talk about our story in the good note right now because the laptop is ready for you and then I think in M604 we arrive at the story about the force on current carrying conductor right and we arrive at somehow the formula oh no I think yes did you arrive at the force equation in equation force formula in equation 33ถึงตรงนี้แล้วใช่ไหมครับ regarding the YouTube okay yes we arrive at somehow here right this is magnetic flux page 81 right no this is 67 okay we arrive at equation 33 in it's something about the force which is caused by the charge moving through a long straight copper wire or conductor right in moment this one we don't need that at all okay yes the total force is the summation of all n forces. Okay, the force that that happens to each charge that is moving in the conductor, right? Yes. According to the last time before the midterm exam, we said that we have totally n number of charges, right? Which is this one, okay, the capital N. And so therefore we have n forces, and each force has the subscript a small letter of n here, and we make the summation in order to get the total amount of force, okay, that acts on that conductor. Well, assume that the force is controlled or followed by the force follows the superposition. Okay, you have the first force, you have the second force, so you have totally n forces, okay, that happens to this conductor. And of course we are using the basic idea from the former topic, which is the force that acts on that acts on the charge, right, which is QVB, right? QVB sin theta, and we're gonna use ผมลองsorry ผมอยู่ที่หน้าของเขาเรียกว่าอะไรใช่ขออภัยครับอัครวัฒน์ครับขออภัยครับไม่ต้องอัครวัฒน์ไม่ต้องเช็คชื่อแล้วนะครับคุณแค่พิมพ์ชื่อมาครับมันเสียเวลาครับโอเคผมอยู่ที่หน้าของ Good Note ครับมันจะไม่แจ้งครับใช่ไหมครับ so here we just follow the idea of the idea of I don't understand why. The idea of force on each chart, right, is FQB sine theta. And according to the scenario there, we assume that the angle is 90 degrees, so it's a right angle. And the total amount of charge is defined before, right? It's in equation 31. In the velocity is just the ratio between the distance per time, right, which is given by equation 30. And the scenario of movement was already explained to you previously in figure 32 and figure 33. Okay, we need to follow the second equality in equation 33, right? The total amounts of charges or n charges, right, is the capital Q, and the velocity is from equation number 30, so it's L by delta T, right? And of course we are going to use the typical expression of current, okay, which is the movement of n charges, or simply speaking the capital Q, okay, per time, which is delta T. So we have in equation 33 the amount of total charge, which is Q, right? So you can see that Q from 32 is going to be Q equal I times delta T, right? You just move delta T to the left hand side, so you get the expression of capital Q. Okay, and that's why you get I delta T here in this scenario, in this equality. And L by delta T still remains there, okay? And what finally we can see is that you have both delta T at the numerator, okay, at the upper side, and the denominator as the lower side, right? So you can cancel them, okay, and the remaining thing will be only I, L, and B, right? And that's the result in the last equality in equation 33. Okay, if what happens if the angle between the magnetic field and the current movement is not right angle, okay, it can be any angle, okay, which is between 0 or 0 to 2 pi or 180 degrees. Okay, yes, the idea can be extended from the former expression, okay, and the idea is the following. In order to describe this, we change the angle variable from theta to phi, okay, in this on this page. The reason behind that is the following. I use the notation from two different books. So sometimes they use theta for the angle between the magnetic field and the current movement, right? So in this case, in the general case, here is the magnetic field vector and the current just move along this way, right? And we get the direction of the current. Okay, the current is not vector quantity, okay, but together with the length L, okay, which is the length of the conductor, we can say it's vector L, okay. The size is followed by the size of the conductor, but the direction of this vector is going to be the same direction as the current movement. In of course, we can extend the result from equation 33, okay, if ILB as in this way, okay. B is the B right angle, okay, the perpendicular ผมอัครวัตรโอเคมีใครให้ผมต้องกดให้คุณเข้าอีกไหมครับมีไหมเอ่ย you are now 15 on the Zoom and here we have the results on 33, okay. The perpendicular magnetic field is the B with the subscript perpendicular notation, and we're gonna replace the B with perpendicular side by B side phi or B side theta, up to you, okay, because we have to consider the component that is perpendicular to the current movement vector, okay, or current direct movement direction, which is this way, right? And the significant or the important component is gonna be this one, okay, which is 90 degrees with respect to the direction of the current. It's decomposed as B side phi, right? Okay, phi is the angle between the magnetic field and the current movement. And you may ask me, why don't we include the effect of the B parallel? Okay, B parallel is the component projected onto the conductor. Okay, we don't need to pay attention to or to take care of that, because this will be in the same way as the current movement, and from QVB side theta, when the angle between the magnetic field and the charge movement is 0, so it has nothing for us, right? It's meaningless for us. So we will the important thing for us is going to be only the perpendicular component, which is side phi or side theta, right? It depends on each server books, okay, or it depends on server books. So 34 is what we can, is where we can find the magnitude of the force. But in physics, we have another thing to pay attention, which is the direction, right? So in order to find the direction, is we're gonna use the same way, okay? As you have seen before, F is Q and V cross B, right? Which is the velocity of the charge, velocity vector of the charge, and the magnetic field vector of that environment. But when we extend it to the long straight copper wire or conductor, we will have a new way which is no longer QVB. Okay, it's ILB. Okay, with this expression you can determine the force direction. Okay, but if you want to find the magnitude, you just apply 34. Okay, this relation. Okay, that's the again the cross product of the vectors. So let's practice ourselves to find the direction of the induced force in this scenario. Okay, please note that F is okay, F is I vector I sorry I okay I and L vector L cross B, right? The first vector you have to take care is the vector L. Okay, you can see it's not vector. It's a scalar in this expression, but together with the current direction, we could say this is the vector L. Okay, and okay, this is the vector L, and vector B is over there, right? You just use your right angle, you turn rotate your four fingers from vector L to vector B. Okay, your thumb direction is gonna be pointing. It's gonna point upward like this. Okay, and here is the way you apply the right angle. ตรงนี้พอเข้าใจนะครับจากเวกเตอร์ I ไปเวกเตอร์ B นะครับคุณหมุนมือขวานะครับ and next scenario, if the angle between vector L and vector B is greater than 90 degrees, what is going, what will happen to us? Well, we just use the same way. Okay, B is I, right, and vector L cross vector B. Okay, you just start from the vector I to the second vector, which is vector B. Okay, this is the vector L. You rotate your four fingers. From this one, your thumb direction is gonna be pointing downward like this. Okay, so that's why we get the output direction of the force, of the induced force. Again, ILB. Okay, I is the current. Okay, but it's not meaningful for us in this expression, in this step. IL and then B. Okay, so you have ILB. You again, we need to start from the first vector, which is vector L, and we curve or we rotate our finger from vector L to vector B, right? Even it's pointing, even both vectors are pointing in the negative direction. For example, the magnetic field is pointing to the negative direction of the x-axis. The vector L is pointing in the negative part of the x-axis and the z-axis. Okay, but it doesn't matter. Okay, because the Cartesian coordinate is just assumed configuration, but the reality for us, or something meaningful for us, is the quantity is related to physics. Okay, which is L, B, and F. So L to B, we can use again our right hand, and we get the thumb direction pointing upward like this. Okay, here is the scenario. We can determine again the force induced onto that long straight copper wire. So from the theory of force induced to the long straight copper wire, what happens to us if we don't have the long straight copper wire at all? Okay, and most application or most scenario that take place in nature may not entails the long straight copper wire. Okay, we may need to face with we have to face with the copper wire that is not exactly linear or straight. Okay, and one application of that is the the speaker. Okay, we have the conductor. Okay, uh, wired into this core. Okay, and we have the long straight copper wire, but we just rotate it, okay, along this core, and this core is placing is placed around the permanent magnet, and we will see what happens if we let the current flowing from lower part to the upper part. Okay, and this coil is called white coil. Okay, if you have a broken speaker, you can disassemble, okay, and disintegrate it, and you will see that there are 3 or 4 components. Okay, the first one is the paper cone, the second one is the watch cone, the third one is the permanent magnet. Okay, and it has the E shape. Okay, you can see this is the alphabet E in English. So we let the current, okay, pass through this conductor. Okay, it's gonna be like a solenoid actually around the paper core, and the cross symbol means the tail or the rear side of the arrow, right? So the dot here is the head side of the current movement or the current flowing. Okay, so the current flow from the lower part to the upper part, but this is the cross-sectional view. Okay, it's you have the complete round around this cone. In they say the F vector is pointing to the left, and what is the reason behind that? มีคนพอนึกออกไหมครับว่าทำไมมัน F มันชี้ไปทางซ้ายครับ Okay, in reality, the shape of the paper cone, okay, will be attached to a frame of the speaker, and there will be a viscous material that leave this paper cone to the speaker frame, but the paper cone still can move easily. Okay, and it will return to the same position when there is no force. Okay, but when you have the current and there will be induced force. Okay, the force will try to push the paper cone into the permanent magnet. Okay, it depends on how strong of the current. Okay, because as we have seen in 33 is the F equal ILB, right? And actually sine theta as well, but theta in this situation is 90 degrees, so it's gonna be number 1. Well, how could we determine, or how could we say the force direction is pointing to the left? Well, we can use, or we can apply the right hand rule again. Okay, let's consider or take a look at the upper part first. Okay, you can see that the current direction is out of the plane of the lecture notes. I don't know how to. Okay, let's switch to the camera and again on YouTube. In Zoom. Okay, let's talk about me. Okay, yes, the force the current is moving, okay, into this limit, okay, to you, okay, and the upper part of the voice coil has the current pointing to you, okay, in this direction to you, okay. เดี๋ยวผมปรับกล้องก่อน okay, it's pointing to you like this, right? Where is here the camera, okay, it's pointing to you, and the magnetic field is pointing, the magnetic field is pointing to the north to S, right? Let's take a look at the figure, okay. As you know, the magnetic field line, aside from the north pole to the south pole, right, it just run through the air or any empty material like this, okay. It's when there is no spatial type of magnetic field, okay, no spatial shape, the magnetic field line just goes straight like this, okay, as the line, okay, as a straight line. And you have now the two vectors, right? The vector L, okay, which is in the same way as the current, and you have vector B, okay. Vector L, it's is in this direction, right? And vector L, to you, sorry, vector L is in this direction, and the B vector, okay, is pointing upward. Okay, let's talk about the first part of the voice coil, okay. The vector L is pointing in this way, okay, to you, okay, and the vector B is pointing upward. So you can apply the right hand rule, okay, from L to B, right? You get the force induced in this direction, okay, to your left hand, okay, which is in the same way as the lecture notes, okay. That's the upper part of the voice coil. But for the lower parts, the current is flowing into the plane, okay, in this direction, right, in this direction. So to me, right, in L, and but the B vector will start from the north pole to the south pole, okay. So because south pole, it's E letter, right, E shape of the magnetic permanent magnet. So the vector L, right, to the vector B, okay, you can apply L and B, right. You get the direction, you get the direction of the induced force in this way, okay, again to the left, okay. And that's why the total forces, okay, which is caused by two separate forces, okay, are pointing in the same way to the left. So that's why we get the result of the force pointing to the left like this, okay. So that's the reason sorry. And how strong is the force, okay, will depend on the strength of the force depends on this expression, okay. Depends on I, it depends on B, okay. And if you want if you want a very good speaker or sound, you should have the bigger paper cone, and in order to move the big paper cone effectively, you need to have more force, and in order to get more force, we have to insert more I, okay, current, or the B, okay, because L is fixed. And B, okay, so you can see that in the big speaker, they have very big permanent magnets. And if you want to get the sub bass subwoofer, a very low tone. Okay, you need to insert more I, okay, and it consumes a lot of power. Okay, and let's take a look at the first example we have here in slide number 90. It's the lightest bird. Okay, it's, you may know that it's hummingbird. Okay, but sometimes the people say it's a kind of bee. Yes, it's in the same size, the same scale as bee. So sometimes the people say it's bee hummingbird. Okay, it's very small, it's tiny. What happened with this bird? Okay, it's just stay on the long straight copper wire. Okay, and they didn't talk. They didn't say about the magnetic field at all. Okay, either in direction or magnitude. Okay, they didn't talk about the magnitude, but they say the mass of the bird is 1.6 gram. Okay, which is very, very light. Okay, it's a small animal. And the bar here, okay, is called perch. Okay, and it's made of a kind of metal, so it can be considered as long straight copper wire for us, because they let the current from flow from the left side to the right side. Okay, the vector direction for the L is gonna be pointing like this, but